Hello, we have chosen the first topic of our Smart School Hackathon, which is a device that indicates noise pollution in classrooms. For this, we have made a prototype which works on principle of decibel management with the help of Arduino. This prototype can be installed in classrooms. We have set different decibel levels for different lights which are green, yellow and red. If the noise is bearable and we can means there is a no problem for hearing, then this prototype will show green light. If the noise goes to an extent where the student should reduce the voice, then the yellow light will glow. And if the noise is unbearable and it goes beyond the level of yellow light, then it will show red light, and simultaneously this speaker will ask the students to keep quiet.
This is the overall circuit for our project. It can be divided into three parts, that is speaker, the sound sensor and the LEDs. For the LEDs we have given a ground connection which have been connected to the three negative pins on the LEDs through a 10k resistor and for the positive input they have been connected to the positive pins on the LEDs through the three digital pins that are 8, 9 and 10 from the Arduino. For the sound sensor we have connected the signal pin, say analog output pin, to A0 port of the Arduino, and the negative and positive have been connected to 5 volts and ground of the Arduino. For the speaker, we have used an LM386 audio amplifier. Its pinouts are 1, 2, 3, 4 and 5, 6, 7, 8. So 1 and 8 have been connected through a 10k resistor, which these 1 and 8 pins are also known as gain pins. By connecting a 10k resistor, we have reduced the audio's distorted effect. The pins 2, 4 and 7 have been connected to the ground of the Arduino, and the pin 3 is connected to the pin 11 of the Arduino, which gives the audio input to the amplifier, and pin 5 is connected to a 1000 UF capacitor. This capacitor then gives the output to a pin and goes to the positive of the speaker. The negative of the speaker has been connected again to a ground of the Arduino. The circuit diagram for the audio amplifier is this. So as I explained, 247 are connected to the ground of the Arduino, and audio input is given through 8.3 volts have been given to the 6th pin, and 1 and 8 have been connected to a 10k resistor, and from 5 the audio's output is given amplified output, and through a capacitor of 1000 UF it is given to the speaker, and negative is connected to ground. So the working of the circuit is as follows. The sound sensor has 4 pins, that is analog output, ground, positive and digital output. Ground and positive have been connected to negative and positive of Arduino, so that the sound sensor has its own power to function. The digital output, the difference between analog output and digital output is that analog output gives an output between 0 volts and 5 volts, whereas digital output gives output only 0 volts or 5 volts. So if we give an output through digital output, we will only know if there is any sound in the room or not, whereas in an analog output we can know if the sound is very high or very low. So in the working, the first step is that the sound sensor gives an analog output to the Arduino. Then this Arduino, because Arduino is a microcontroller, therefore it has its own compiler, and therefore it understands the voltage as the decibel level in the room. And then as it is programmed to function, it will either on the 3 pins, that is 8, 9 or 10, or the 3 pins which are connected to the positive of the LEDs, because the LEDs will already have negative. Giving an positive input to the LEDs, they'll get on. So if the decibel level is very low, then it will on the 8 pin that is connected to the green LED, and then the green LED will glow. If the if the sound is high, then it will glow the yellow LED, and so on till the red LED. And when the red LED is on, simultaneously it will play an output to through the speaker, which will say, students please reduce your voice, so as to inform the students to keep quiet, as the voice is very increasing and that can be harmful to themselves. This is the program for our project. So this here, and in this line, library is being included, that is PCM, by which we could give the which we by which we could this is the program for our project. This is in this line I have given the audio output through a format supported by Arduino. The mp3 file was converted to this format through Java software encoder. There are three if blocks, that is first, second and third. So if the decibel range is between 0 to 72, then green will be on, rest will be off. 73 to 82, then yellow will be on, red and green will be off. And 82 to 1200 or any max limit can be set here, then red will be on and yellow and green will be off. And simultaneously a playback will start, which will be of almost 3 seconds, saying, students please reduce your voice. And the playback will stop when the decibel range goes to either yellow or green.
As I said, this prototype can be used in classroom. This can also be used in public places and offices. Moreover, this prototype can be installed in music rooms and construction areas, but the only difference would be that the decibel levels will need to be changed.
So as we said, now I'm going to demonstrate to you the working of this project, which is the sound detection module. For the demonstration, I'll be taking the sound source such as a speaker close to it and close to the sensor of the prototype, and you will see how the levels indicate and the speaker gives the output according to the level of the sound.